So now let's have a look at the different structures of LA. In general, they are divided into amides and esters. In terms of the name, you can see that all of them would have a suffix at the end. The suffix cane, C-A-I-N-E, is reserved for local anesthetic. Yeah. So whenever you see a cane at the end when you go to a pharmacy, or you go to, if somebody give you a particular ointment and it says cane at the end, usually it will mean a local anesthetic. Yeah. And how can you tell a difference between amide based LA and an ester based LA? They all have the same suffix here. So if you see at the end here, for esters, you have cane and they wouldn't have an I at all. All right, so benzocaine, cocaine, and so on. Let's have a look at amides. Amides will have cane and it will have an I. Can you see that? In the middle of the name. All right, so look for the I. Yeah, look for the I for amides. Yeah, that will tell is an amide based LA and an ester based LA. In terms of the clinical, usually the ester based LA would patient would complain of the ester based LA for allergies. That's usually the case. Yeah. All right, let's have a look at the structures, because the framework of LA, because they're quite varied in a sense. Yeah. For LA, usually you can divide, if you actually put them across like this, and you can actually divide them as they're having a lipophilic moiety, they have the intermediate chain or a bridge, and lastly they would have the hydrophilic portion. Now, let's have a look at the first one, the first part of what all LA would share, the common structure features of what LA would share. The first one would be the lipophilic portion, and you can see that they all, without fail, would have an aromatic ring. So when you see like this, what happens is that when you see this structure feature, that is the aromatic ring, the first thing that would actually should strike you is that what is the aromatic chemistry for this LA. So please relate back to what you have learned in FAR 113, if I'm not mistaken. Yeah? I bet you have learned about aromatic chemistry, and this is where you can apply your knowledge in aromatic chemistry. Okay, let's have a look quickly on the lipophilic moiety or portion of this LA. Firstly, you have to know is essential. This part is you cannot do without. And if you see in the mode of action, in mode of action B, this particular part of the molecule actually binds to the phospholipid. Okay, so what they normally have is either just an aromatic group, linked to a carbonyl in this case, or maybe you have something like a 2,6-dimethyl group linked to an amine or amide. Yeah, and usually, this will help in terms of its action, in terms of this electron density of a part of molecule, which is important to its mode of action. Okay, and the electronic factors involved are resonance and inductive effects. Let's have a look at each one in turn. Yeah. So when you have, example, this is procaine. When you have an amino group, please review your aromatic chemistry. This actually will form resonance. There are a few resonance forming here. If you look at the orbitals, it means that the parts of molecules, electrons in the parts of molecule, this part of the molecule is being shared by the atoms around that. Yeah, so that makes it very stable, and it easily will confer good interaction with another, in terms of hydrophobic or van der Waals interaction, with the other side of the receptor, in this, for example, insert for sodium channel, or maybe in terms of the first hurdle they have to overcome is the phospholipid. Okay. Now let's look what happens when you change the moiety on one end. Yeah. So with the amino group it's fine. All right, it's favorable. All right, but then if you change the amino group to a nitro group, okay, it becomes unfavorable because the nitro group is an electron withdrawing group. It will just pull it away. Yeah, pull it away. Pull the electrons away from the cloud. Therefore, it's usually when you have a nitro group at one end of an LA, it would result in a weaker activity in an LA, yeah? Because that part of molecule wouldn't actually be shared. And another thing as well that I should mention here, if you see the end result of the resonance would be zeta ion. Yeah, there's a plus here and there's a minus here. So there's an internal zeta ion that is favored for binding of LA to the receptor. So in this case, in the case of nitro, the formation of the zeta ion is unfavored. Having the CH2, moiety is also leads to unfavorable position, yeah, for this particular molecule because it inhibits the formation of zeta ion. Yeah, the same goes now. This is para substituted. If you have a meta substituted ring, aromatic ring here, again is unfavorable. There's no resonance stabilization, also very little or hardly any zeta ion formation. Therefore, it's usually used to improve the hydrophobic interaction. Okay, now so all this is about resonance. Now we're going into the inductive effects. Yeah, so have a look at this one. This is tetrakane. This is a very, very good LA, and is actually a derivative of procaine. It's inspired by procaine, and the difference is just it has an N-butyl group, a long chain N-butyl group at the end, and with that modification, what happens is that tetrakane is 50 times more potent than procaine. Yeah, so that sort of emphasize the importance of resonance because this group is thought to helps in terms of pushing in the electrons into the resonance formation and therefore helps in the formation of the zeta ion.